Welcome to lecture 3 in Introduction to Applied Internet of Things. This is programming part 2. Today we are going to discuss conditions. Sometimes we need to compare things. We sometimes need to evaluate if one thing, for example a variable, is greater than another one. A comparison is either true or it's false. A comparison, let's see here. In the first line here it says A greater than B, and if you have that comparison, it's true if A is bigger than B, not if A is equal to B. If you want to have greater or equal than B, you have the second one, A is greater or equal than B. If the same thing with less than, if A is less than B, you use third one. And if you want to allow that A is equal or less than B, you should equal or less than B. This one. If you want to have a comparison with something is equal, you have two equal signs. And the last one, A is not equal to B, and that's using an exclamation mark equal sign. So that's not equal. Some of the most common variable types in MicroPython is integers. We will use those in this lecture. Sometimes we use float, and float is a decimal number. And remember that we are using decimal points in MicroPython, not comma taken signs. We use string for text, and for example when we use the print command, and always use quotes, either single quotes or double quotes. Sometimes we want to store a condition or a comparison, and that's either true or false, and that's the fourth one, the boolean, and the fifth one is a list. That's a collection of value, and we can have a fixed collection that we can't change. That's called it's immutable. That's a tuple. And then we can have something called key value pairs, and that's stored in a dictionary. An if statement. We use an if statement to check a condition. If the condition is true, we run the next block of code. For example, here we have temperature is equal to 13, and then we have a comparison. If temp equals 0, that means a comparison. That's not true because it's 13 is not the same as 0. Then we will not print temp is 0. Then we have the next row, elif, that means else if, and that's optional if we need it. And here is just something wrong here. I'll write x greater than 0, and x should be temp. And temp is bigger than 0, so in this case, if we write it correctly, it should print temp is positive. Else means that if not of the previous conditions is true, this will always be run, and only one of these three block of codes will run, not more. And both elif and else is optional, but you have to have a if statement. We will test the if statement using a button. So I will try to connect a button to my Raspberry Pi on GP15, and I will use this one to the ground. You can use another one. Just check your pin out diagram, and I will try to control this LED here on GP0. So here I have my button. It doesn't work because I haven't connected it. I will, if you see here, I will use one of these pins here to the 15 and the other one to the ground. So here we have it connected, and I will start programming it. We start with import from machine import pin. Then we start with the LED light, and it should be on pin 0, pin out. Then I will use the button. I call it button, and that's on pin 15. I set the mode on input, and I use the internal resistant. Next slide about that. Pin pull up, and that should be point there. Now I will check constant if the button is pressed or not, and I will use a while loop for that. So while true. More about loops in next part, but code here that are intended will run forever. And I want to start with checking if the button value, and don't forget the parentheses, is equal 0. That means the button should be pressed. If the button is pressed, I want to turn the LED on, and that's the same as value value 1, but I can write on. Else, that means it's not 0. Then I will have the LED to off mode. And now I want the computer not to run every clock cycle. I want to have a small sleep, and I will show you how to import it. I can start with import time, and after here in the while but not in the else, I use time sleep and 0.01, that means 1/100th of a second. If you don't want to write time.sleep, you just want to write sleep, you have to do like this, from time import sleep. And now we will run this program. And hopefully, if I press the button, the LED will turn on, and I release it. So it's working. So back to the PowerPoint. Here is the hardware setup, as I showed you. And here is the code. This means 15. The pin in means that the microcontroller pins the pin to input mode. That means we are reading from it. And the pull up turns on an internal resistor that keeps the pin on high value. That means 1. When we press the button, it will turn into 0. So in the while true loop, we will check if the button dot value, that means if we press it, it will be 0 because we have the pin dot pull up. We turn the LED on, else we turn the LED off. A more complicated example is a moisture alarm. In this program we will try to create a moisture alarm. We will use this blue sensor. It's a DHT11, and it measures moisture and temperature. And in this example I just will measure the moisture, and I will use this black one. Is a passive piezo buzzer. You will hear it. And piezo use PWM. We have talked about that protocol earlier on. And the DHT needs a library that's available in MicroPython. And in this case we will power these ones from the VSys, and we will use another ground that's on pin 38, I guess. You can see it here, it's black here. I will show how it looks. It's not really that pretty when you not do it in this program. So here we have it. But here, that's are used to measure the DHT11 sensor, and the yellow one here is to activate the piezo. So we will start programming it, and I will start by using some imports from machine. I will import, of course, pin, but I also this PWM that's located there. From time I will import sleep, and I will import DHT. Maybe we'll change that later on, but first I will control the buzzer that's located on the 15, the yellow one here. I call it buzzer equal PWM, and this one use a pin. So I will place a pin inside the PWM, and this one needs a frequency as we talked about in earlier lessons. Freak, and I started with 1000, and the next one is this is the buzzer. I will use the DHT sensor. I call it sensor, and I will call it DHT.DHT11, and here I place a pin, and if I don't want to write all this, I can just use like earlier on, from DHT import DHT11. And here I will have pin 14. Don't forget that you have equal amount of right and left parentheses. Seems right here. Now I have my sensors control. I will use this print here to see if it's working. While true, sensor measure, and then I can get the humidity, sensor, don't forget these ones, and I just print it. print and that will be in this form. If I have a string here and then a comma, then this one, it will print first this one and then a space and then this one. So we have a sleep here for 1, maybe 2 seconds, and just run the program to see if it's working. And now it says 30, and yeah, it's reading it here. Oh, working, great. Stop it. Now I will have an if statement here. If humidity is greater than 35, we want to turn on the bus. And that's using the duties as we talked about in earlier lesson, and the command is the buzzer.duty underscore, and here is a number between 0 and 64,000 something. I will use half of it, and that's 32,768. Really not that important. Else warning, and then we use the buzzer, set the duty to 0, and then we have the sleep. I will run the program again, hopefully no errors. Seems correct. I will try to activate by blowing on this one. Hopefully that's enough. It's increasing. Then here can hear it, and it will turn on until it's less than 35 again. And if it's too annoying, you can just pull the sound off this one. Or you can, yes. So here is a more complicated program. So it's a moisture alarm using one sensor and one buzzer, and just a if statement to check if the moisture is too high, it will turn out. And the code here is the most important thing is don't forget the PWM and the DHT protocol. Here I doesn't use the from DHT import DHT11, so you see the full line here. You can decide what you want to do yourself. And if the humidity is over 35, we turn the buzzer by duty to this. That means 50%. If it's under, we set it to 0, and let's see if it has been less now. No, it's still high. So I will disconnect the sound here on my my moisture alarm. So this is a complicated but quite easy project to start with to train how to work with the if statements. Good luck!